Okay, in this video, I'm going to draw a simplified version of a ribosome. And I will note that this is for a bacterial ribosome. So parts of it will be the same as what we see in eukaryotes, but when I start talking about the sizes of different components, that'll be more specific to what we see in bacteria. So we have a small subunit, and we have a large subunit. That's all right, that'll work. And in the small subunit, we do have a couple of important components that help orient the messenger RNA as it is fed through the ribosome. But in the large subunit, we have these three very important catalytic sites. The exit site, where discharged tRNAs are yeeted out. The peptidyl site, where the growing polypeptide is held. And the aminoacyl site, where new transfer RNAs with amino acids are fed in and either match up with the codon with the anticodon, or that process can repeat with different transfer RNAs until the proper one actually gets fed in, and there's a match between the codon on the messenger RNA and the anticodon on the transfer RNA. So A is for the aminoacyl site, which is the acceptor. P is for peptidyl donor site, and E is just for exit. All right, so here's where we're going to get specifically into what we see in bacteria. So the small subunit measures at 30 Svedberg units. It is comprised of a 16 Svedberg ribosomal RNA, often just called the 16S rRNA, and there's 21 different polypeptides that also comprise the small subunit. Altogether, it weighs around 1 million Daltons. The larger subunit is the 50S subunit, and it has two different ribosomal RNAs in it. It's got a 5S ribosomal RNA, and it has a 23S ribosomal RNA molecule, and it's got 34 different polypeptides. And it weighs in at about twice the size, at about 1.8 million Daltons. So together, the two subunits form a 70S ribosome that weighs in at about 2.8 million Daltons. So I'm going to zoom in a little bit and show you how we initiate translation in bacteria. All right, so first we're going to start off with our 30S subunit. And you might wonder what prevents the 30S subunit from just binding to the 50S subunit and spontaneously. And it turns out we have a number of factors called initiation factors, which are 1, 2, and 3. And the 30S subunit, when it is not bound by a messenger RNA, IF3 prevents 30S from binding 50S subunit. So the next thing we need, I'll just label that a little more clearly. That's initiation factor 3 right there. So next we need our messenger RNA to come into play. And we're also going to need our first transfer RNA. So if you can't draw something clearly, you should at least label it. So this is going to be our first tRNA, which contains a specialized methionine residue called formal methionine. And because it's this specialized methionine, it's called an FMET tRNA, formal methionine transfer RNA. And we're also going to need a molecule of initiation factor 2 plus a molecule of GTP for energy. And the 16S ribosomal RNA is going to bind to the Shine-Dalgarno sequence, which is in messenger RNA. And that's going to enable the FMET tRNA with the help of initiation factor 2 to bind at the to bind in the correct orientation. And while this is happening, we're also going to have our third initiation factor, which is initiation factor 1, is going to bind to the 30S subunit, which causes initiation factor 3 to leave. So, yeet. Okay, so now we've got our 30S ribosomal subunit with the 16S our ribosomal RNA binding the Shine-Dalgarno sequence. We've got our initial codon, AUG, and initiation factor 2 is going to add our FMET tRNA to bind to that start codon. And once it's done that, in comes the 50S subunit. So we've got our messenger RNA at the 5' end there, 3' there and there. IF1 bound to the 30S subunit. We've got our AUG, which is bound to our formal methionine. tRNA with its anticodon, it's going to be CAU. And doot. Once that all comes together, so as 50S binds to 30S, that GTP is hydrolyzed plus initiation factor 2 hydrolyzed. And then IF1 and IF2 are going to be released. And now we are ready to rock and roll. So here's a transfer RNA, charged tRNA. And at this point, now we've got our complete yeet CIF1 70S ribosome. Okay, it's not my most elegant drawing, but hopefully it gets some of the points across about what the roles of the different initiation factors are as we initiate translation in bacteria.